so before we get into some application problems, aka word problems, just some helpful notes. So example 3, we're finding the height of a tree which casts a shadow of 12.4 meters when the sun makes an angle of 52 degrees to the horizon. So it's a lot of information. They gave us a diagram in this one though, so that was nice. So just to kind of point out key things in the diagram, we're looking for our height, which they labeled as h. The tree itself casts a shadow, which should be on the ground. That's why it's on the bottom part. Casts a shadow of 12.4 meters. And the sun makes an angle of 52 degrees to the horizon. So that's where they're getting this 52. So we can see that outline of the right triangle we're looking at. We're assuming this tree is perpendicular to the ground. So we're going to assume that's our right angle there. So kind of figuring out which trig function we're going to use. I'm looking at this angle. I'm looking for the opposite side. And I'm given the adjacent side. So again, thinking about SOHCAHTOA, opposite and adjacent means I'm using tangent. Writing this out every time, it's your choice. I always do it for the first few problems just so that we remember what we're using and what we're looking at. But filling in what I know my angle that I'm focusing on is 52 degrees. I know the opposite side is what I'm looking for. It's that h that I'll go ahead and leave there. And my adjacent side is 12.4. So again, just like example 2a, I can set up a little ratio here by putting that tangent over 1 and cross multiplying. So I would have 12.4 times the tangent of 52 degrees equaling the height. If I go to my calculator or go to Desmos to type that in, again, using regular tangent here, since I'm looking for the side. 3 significant figures, I'm looking at 15.9. Example 4, a 12-meter ladder is leaning against a wall. They didn't give me a picture this time, so I'm going to start drawing a picture just with that information. I know we're focusing on, oh boy, right triangles, so I'll try drawing a right triangle. The ladder itself is leaning against the wall, so that implies that it's the hypotenuse. So this is my 12 meters. We're finding the distance from the base of the wall. So this is the base of the wall to the top of the ladder. So I'm looking for this distance. If the ladder makes an angle of 44 degrees with the ground. So with the ground and the angle between those two, that's where the 44 degrees is. And so let's figure out what we have here. If I'm focusing on that 44 degrees, we're looking for the opposite. And we have our hypotenuse. So opposite and hypotenuse, that means I'm looking at sine. Again, filling in what we know. I know my angle is 44 degrees. I'm looking for the opposite side, and I have my hypotenuse of 12. So another one where we can cross multiply or just multiply both sides by 12. It's not always going to work like that. It's just coincidence that a lot of them happen. Sometimes the variable and the number you're looking at or the number you have are switched. So this could be like 12 over x. So that's why I'm just emphasizing the cross multiplication, just in case it's something like that. And 12 times sine of 44 equaling x. So again, going to my calculator or to Desmos is 8.34 rounded to 3 significant figures. Meters. All right, and the last major thing we're going to talk about, dealing with the application problems. Sometimes you'll see an angle of depression or an angle of elevation. So just kind of pointing out what those exactly mean. An angle of elevation is the angle between the horizontal and the line and your line of sight to an object above the horizontal. So you're elevating your line of sight from the horizontal up to the object. So in the picture that we have, up to the line or the object that you're looking at. So this would be the angle that we're looking at from horizontal up. versus the angle of depression is the angle between the horizontal and your line of sight to an object below the horizontal. So it always starts, no matter if it's elevation or depression, it always starts as at a horizontal line and then either opens up or it opens down. So with our angle of depression, meaning I'm going down, it would be here. All right, fifth and final example. An observer is standing at the edge of a cliff 82 meters above sea level and sees a buoy at an angle of depression of 26 degrees. How far from the base of the cliff is the buoy situated? So let's get a picture going on here. We've got a cliff with someone standing on top of it. That cliff looks out to sea. And we know that cliff is 82 meters above sea level. We also know that this observer sees a buoy somewhere out at sea, so here, and they're looking at it. So now they don't tell us how tall that person is. So we're assuming, since we don't know their height, we're assuming that maybe instead of standing like I have them drawn, that they're laying down and they're looking at it from the edge of the cliff. I'm going to come back to the angle of depression in a second. We're looking for how far from the base of the cliff is the buoy situated. So from the base of the cliff to the buoy, we're looking at this length, or we're looking for that length. The angle of depression, remember, always has to come from the horizontal. So if this person is laying down and looking down at the buoy, they're looking out from the horizontal. We're going to pretend that's a horizontal line. It's going down, or their line of sight is going down 26 degrees to that buoy. So this is where the 26 degrees is going. So kind of refocusing on what the triangle is that we're looking at. All right, so just emphasizing the triangle we're looking at. We're also going to assume that the cliff and the sea meet at a right angle, or a 90-degree angle. And we know we have the height of 82 and we're looking for this length of x. The question is that 26 degrees technically isn't inside of our triangle, and we can combat that two different ways. We can remember from geometry that if the horizontal that we sketched in and the cliff are also complementary, or they add up to 90 degrees, I can use that to find this angle of 64 degrees. By just subtracting 26 from 90. I can also remember from geometry alternate interior angles, that since both the sea and my sketched in horizontal line are parallel, then if this angle is 26 degrees, this angle is 26 degrees. It doesn't matter which angle you focus on, either the 64 or the 26. It's going to change what your work looks like, but the final answer will be the same. So I'm going to first focus on the 64. So if I'm looking at my 64, I'm looking for the opposite, and I have the adjacent. So that tells me tangent. And so filling in stuff that I already know, tangent of 64, that's the angle I'm focusing on, equals the opposite over the adjacent. And solving that for x, I can again cross multiply. And then I can go to my calculator or to Desmos to type it in. And I get around to 3 sig figs, 168 meters. Alternatively, if I wanted to focus on the 26 instead, I have my opposite and I'm looking for my adjacent. So it's still going to be tangent, but now tangent of 26 degrees. And that's going to equal, my opposite is now 82. And my adjacent is x. So again, now cross multiplying. So isolating my variable, I'm typing in the 82 divided by 26 to my calculator or to Desmos, and I'm still getting the same answer. So just to prove that, it doesn't matter which way you look at it or which method you use, you still get the 168 meters. All right, so to wrap up, here's some practice problems you can do. Make sure you pause to try them on your own and then continue on to get the answers. And here are your answers. And we got one more page of practice problem. So again, I encourage you to pause and try it on your own before looking at the answers. Part number D might help if you draw a new diagram, replacing that original 30 degrees with the 55 degrees that they're looking for the maximum height. If it's at 55 degrees, what's that maximum height? So it might help to draw a new diagram. And there is the answer for that one. So I hope right triangle trig helps make sense. Again, remember, always draw a triangle or always draw a diagram if they don't give you one, just to put all of the information into one place.